Okay, guys, here we go. It's Tuesday, June 2nd. We're at Unit 10, Lesson 2.
It's party time!
Getting closer.
Please, come closer. Too close, a little too close.
Our goal today is to look at central tendencies of data, and we're actually going to spend a minute looking at a dot plot really quick. Okay, so measures of central tendency. What does that mean? Okay, that's just a fancy way of saying I want one number to describe all of my data. In other words, today we're going to look at mean, median, mode, and the range, which we briefly looked at yesterday. The mean is the average of your data. It's got sometimes an X with a bar like that. You'll see it with the mean. There is a way to find quickly the mean, median, and mode in your calculator, but it's way too hard for me to do on this video. But if you want to YouTube it or Google it, feel free and just Google how to put it in the TI-84, whatever calculator app you have, and it might make your life easier, just saying. Okay, so the mean is just a fancy way of saying the average. It's kind of like before you were home, what we would do with your grades, add them all up, divide by the total, right? So that's how you find the mean. You add every single piece of data, divide by the total, and you get an average score. The median, which we talked briefly about yesterday, median in a road is the middle of the road. You don't want to run that over, okay? Median looks like the word medium, which is the middle size. So the median is the value or the number that lies in the middle once you put your numbers in order from least to greatest. So they can't just be random and all over the place. To find the median, you're going to order the data, the numbers from least to greatest, from smallest to biggest. And then I just like cross off on the sides. Now, here's the deal. If you have an odd number of data, so say you have 13 numbers, you will get an exact middle number. You're going to like cross off. If there's 13, you'll cross off 6 on both sides, and you'll be left with one number in the middle. That's the median. If there's an even number of data, so when you cross off on the sides, there's 2 left. So if I had 14 numbers, an even number, when I cross 6 of them off from both sides, I'm going to be left with 2 numbers in the middle. What you do then to find the median is you do the average of those 2 numbers. So in other words, if there's an even number of data, you take the 2 middle numbers and you add them up and then divide by 2, and that'll give you the median. The mode, M-O-M-O, most, okay? It's the number that's there the most. So if we were doing this in September in class, the mode probably would have been 14. That's my guess, that most of you are around 14 in September, okay? Maybe by the end of the year, most of you are 15, right? My age was definitely not the mode in class, okay? So if there's no mode, so if there's no number that appears more than once, then there's just no mode. If there's more than one, it's okay. So say we had 12 14-year-olds, 12 15-year-olds, and a 16-year-old. Well, 14 and 15 could both be modes because they're there the most amount of times, okay? The range, like we talked about yesterday, it's the difference between the highest and lowest numbers. So you literally just subtract the biggest number given and the smallest number given. Nice and easy. So let's practice.
Are you crying? Are you crying? There's no crying. There's no crying in baseball.
This says the scores of 9 students' histograms are shown below. To find the mean, well, what you're going to want to do is add them all up. I'm going to write this one and only this one out. So you're going to do 85 plus 72 plus 100 plus 50 plus 88 plus 76 plus 65 plus 90 plus 85. So let's actually do that in the calculator. I'm going to take all of them, say 85, 72, 100, 50, 88, 76, 65, 90, and 85. I get a number. When I add them all up, I get 711. And then I'm going to divide by the total numbers there. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, and they told us that. So we're going to divide by 9. And your mean, I'm going to do that X with a bar over it. That's the symbol for the mean, is 79. So the average test score on this particular history exam was a 79. Okay, kind of get rid of that. I just wanted to show you for that one. I won't write it out ever again. Okay, let's look at the mode. So the mode, is there a number that appears the most? It looks like to my old eyes that it's 85. 85 is there twice, so 2 kids got an 85. Nothing else seems to repeat. The median. So the median is actually the one that you might have to do the most amount of work for, but it's simple work. What you have to do is you have to put them in order from smallest to biggest. So what's the lowest score here was a 50. Sometimes I miss them, just letting you know. And then it looks like 65 might be next. And then it looks like 72. And then it looks like 76. And then I've got 85. I've got 2 of them. They both go in. 85. Every single kid's score goes in. 90. Notice I cross them off as I go. I always have to do that just to double check. And 100. So there they are. I was right about the mode. So the 85 occurred the most. And then to get the median, I just literally cross off. I'm like, if I cross off 1 here and 1 here, and then these 2 cross off, and then these 2 cross off, and look, I have 2 left in the middle. When you have 2, which I shouldn't, because I should have an odd number. 50, 1, 2, 3, 4, 5, 6, 7, 8. What number did I miss? I see it. This is some great learning. Oh, I did. I've just made mistakes all day.
Mistakes is how you learn.
Thank you, Corey.
No offense, your students are way smarter than you.
I know. This is rough, guys. Sorry. Colossal waste of time. Let's try it again. Ready? 50, 65, 72, 76, 85, 185, the other 85. What did I miss the first time? I missed 88, 90, and 100. Let's see if I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here we go. Now let's find the median. So again, we'll cross off. It's an odd number, so I should get 1 middle number. When I cross off, I got 4 on both sides. The median in this case is 85 as well. The range, you just take your highest number, which is 100, minus your smallest number, which was 50. So the range of grades was 50 points. There's a 50-point difference between the highest and lowest. That's it. That's how you find them all. Okay, let's look at this one. It says a 10th student took the same history exam the following day due to an absent that was mentioned in example 1. If the student received a 90, recalculate the measures of central tendency. Okay, so let's go back to the other screen. I'm actually going to do all the work back here for example 2, but it said that the 10th person received a 90. So now when we go back onto this screen, we're going to add another grade in here. We're going to add a 90 in. Okay, so let's find the mean. To find the mean, we add them all up. 85 plus 72 plus 100 plus 50, 88, 76, 65, 90, 85, and 90. Divide by the total. Now I have 10 people here, right? Don't want to divide by 9. I have 10 total scores because this person's now here. So divided by 10. And the average is 80.1, or just 80. So what happened to that average? That person that got a 90 made it go up a little bit, right? The mode here is now 85 and 90, because they both occur twice. There's 2 modes. Let's do the median. Now I'm going to have 10 numbers, so here we go. Let's see if I can do it. 50, 65, 72, 76, 85, 85, 88, 90. Now I have 2 90s and a 100. 90, 90, and 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this time, when I go to do the median, I'm going to cancel out. So 1 on each side. I'm just trying to find the middle. Well, now I know I have 2 numbers in the middle. Well, this is pretty easy, and it would be otherwise. I'm going to show you, no matter what happens in the middle, it happens to be the same 2 numbers, but no matter what, if that happens for the median, you add them up, and you divide it by 2 because there's 2 numbers there. Well, 85 plus 85 is like 170, and 170 divided by 2 is 85. So the median didn't change at all. Is the range going to change? No, it's still the highest number is still 100, lowest number was 50, so the range is still 50. Okay? Let's look at this one. It says, Noah conducted a survey on sports participation. He created the following dot plots to represent the number of students participating by age in soccer and in basketball. So if you look at the soccer ages and then you look at the basketball ages, anything that you can infer about the data before we start? It looks like for basketball, as kids get older, they start to join. Let's see. It says, which statement about the given data set is correct? So number one says the data for soccer players is skewed right. Is that data skewed right? It's slightly skewed right. Okay, that could be our answer, so we're not going to cross it off yet. Let's see the other choices. Choice 2, I'm going to tell you is wrong because we're not going to learn about that this year. So you'll learn about this in Algebra 2, but it says the data for soccer players has less spread than the data for basketball players. That's something called standard deviation, which again, fortunately, we just ran out of time for this year, which is okay. Number 3 says the data for basketball players has the same median as the data for soccer players. Well, let's find the median of both. The nice thing is in a dot plot, you don't really have to list them out. Remember, each one of those dots represents an age. So for soccer players, you have 3 6-year-olds and 4 7-year-olds and 2 8-year-olds and so on. So you can like cross off dots on both sides just like you would crossing off numbers. So what I mean is if I like cross off 3 of the young ones, then I can cross off 3 of the older ones. And then I can say, all right, well, now I'm going to cross off, let's see if I cross off all 4 of these. Well, if I cross off 4 over here, I have 1 11-year-old. I still need to cross off 1, 2, 3, 4. Now I'm getting closer, so maybe I'll just cross off like 1 9-year-old and 1 8-year-old, and I'm left with 2 numbers in between. I'm left with an 8-year-old and a 9-year-old. So now to find my median, I'm going to do 8 plus 9 divided by 2, which is 17 divided by 2, so 8.5. So your median of the soccer players is 8.5. You're 8.5 years old. Let's do the same thing with basketball players. We're set to cancel off. So 1 here and 1 here, and then 1 here and 1 here. And you could do more than I am. Maybe these 2 go with these 2. And then 1, 2, 3 goes with 1, 2, 3. And then look, there's 4 numbers left. So I'm going to cross off 1 and 1. Well, I have 2 numbers in the middle. They're both 10. 10 plus 10 is 20 divided by 2 is 10. So the median here is 10. So let's read option 3 again. It says the data for basketball players has the same median as soccer players. Is that true? Are they the same? No. So that's out. So option 2 is out. Option 3 is out. I'm pretty sure option 1 is out too, but let's see. Number 4 says the data for basketball players has a greater mean than the data for soccer players. So now we have to find the average. You don't have to write these numbers out. To add these up, again, if I want to find the average of the soccer players, I'm going to add them up. So I have 3 6-year-olds. So that's a 6 plus 6 plus 6 plus 6, or you can do 6 times 3. Plus, I have 4 7-year-olds. So 1, 2, 3, 4 7-year-olds, 2 8-year-olds, that's 2 8s, 2 9-year-olds, 3 10-year-olds, 2 11-year-olds, and 2 12-year-olds. And there's a total of, count the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 people. So I got 156 divided by 18. So the average age for the soccer player is 8.6. 8.67 really. Okay, let's find the average age for the basketball players. I'm going to do the same thing. Well, this has 1 6-year-old, so 6 plus 7 plus 2 8s, 8 plus 8 plus 3 9s, 3 10s, 4 11s, and 4 12s. Again, there's going to be 18 people, so I got 178 divided by 18. What do you think is going to happen? It's going to be a greater age. So the average age for basketball is 9.8. So number 4 said the data for basketball players has a greater mean than for soccer players. There is your correct answer. So choice 4 is your correct answer. Not tough work, okay? And you guys should have done mean, median, and mode before in life, all right? Let's look at this question. This is one of my favorites.
Nerd alert!
It says the values of 11 houses on Washington Street are shown below. Find the mean. Now, be careful here. See how it says the value per house and the number of houses? So this means there's one house that's $100,000. There is 5 houses, that's 175,000. So I'm not going to write the whole 1,000 out. I'm just going to write the 100. So meaning I've got one house that's 100. It's going to want me to find the median as well. So I'm going to list them out just to prepare us for that. I have 5 that are 175,000. So 1, 2, 3, 4, 5. Just know that I'm talking about thousands here. I have 4 200,000s. 1, oh, can I squeeze it? 2, 3, nope, I'm gonna go down here, 4. And I have one $700,000 house. So there we go. There's our data. Part A wants us to find the mean. To find the mean, we add them all up, divide by the numbers there. So I'm gonna do the 100,000. So 100,000 plus 175,000 plus 175,000. What would be quicker than me doing 175,000 5 times? 175,000 times 5, right? Plus 175 plus how many 200,000s? There's 4 of them. So I can do 200,000 4 times, or I can just do 200,000 times 4 plus 700. Just make sure I didn't put 2 million. Okay, so I got 2, 4, 7, 5, 1, 2, 3. How many total houses are there? There's 1 plus 5 plus 4 plus 1. So 6, 10, 11. So I'm going to divide by the 11 houses on that street. And the average house price is $225,000. There we go. The median, well, now that up top I listed, let's start canceling out. There's 11, so we should get a middle number. So the 100 and 700 are going to cancel. And then I'm going to cancel this 200 with this 175. And there we go. And I cancel one to the next. So the median here is 175,000. What do you think is the best one? Which number do you think best represents the data? On this house, on this street, Washington Street, our house is typically closer to $225,000. Or are they closer to 175,000? Well, they're closer to 175. So the median is better. The reason that the median is better, look, 225 is above. It's higher than 10 out of 11 of those houses. I mean, I know it's close to the $200,000 house, but it's still higher than 10 out of the 11, right? So the median clearly is the best answer here. Here's a general gist. If your data is ever skewed, the median is going to be the best representation. It's going to be the most accurate number that represents all of the data, okay? So just keep that in mind. Let's look at this one. This one says the table below shows the annual salaries for 24 members of professional sports teams in terms of millions of dollars. Must be nice. That's 7.2 million, huh? Okay. The team signs an additional player to contract worth $10 million per year. Which statement about the median and the mean is true? Well, what do you think is going to happen? Is it going to change? If you don't know, we could figure it out, which is, you know what, we're just going to do that. So we need to figure out if it changed. So let's first figure out what the mean is and what the median is. So let's figure out the mean. In other words, we're going to add all these up. So 0.5, 0.5, 0.6. Bear with me. You should be typing these in your calculator at the same time. I know y'all can text faster than I can, so you might be done already. All right, when I added all these up, I got 61.5 million. 61.5, I'm going to divide it by, there's a total of 24 people. So 2.5625 million is what I got for the mean before we added that other person in. You want to find the mean now? Yeah, you know what? Let's find it now. Let's pretend this $10 million person is in here, which makes life okay. I could add them all back up plus a 10, or listen, that 61.5 was my numerator when I added them all up. So let's do 61.5 plus the 10 million person. So the mean of the new, I have 71.5 divided by, there's now 25 people. So divided by 25, and look what happened. I got 2.86. So now what happened to the mean? Well, it clearly increased. So let's look at our options. Option 1, both will increase. Could work. Option 2, only the median increase. That's not it. We know the mean definitely changes, which means option 4 is out. So now let's go through and figure out the median. Lucky for us, they already put these in order, so we just have to cancel. So I'm going to cancel 1, 2, 3, 4, 5 little guys. And I say little like, yeah, not little money. 1, 2, 3, 4, 5, 6 big guys. Let's do like 1, 2, 3, 4 here, and 1, 2, 3, 4 there. And then look, I'm going to cancel this one with this one, and I'm left with 1.4 and 1.4, which means 1.4 plus 1.4 divided by 2 is 1.4. So the median here is 1.4. Let's see what happens when we add that $10 million guy in. We're going to add them in at the end and then start doing the same thing. So canceling out. So I'm going to do 1, 2, 3, 4, 5, 6 of these guys, and 1, 2, 3, 4, 5, 6 of those. And then if I cancel 1, 2, 3, 4, 5, 6 here, how about 1, 2, 3, 4, 5, 6 there? And what are we left with? Well, the median here is still 1.4. So the only thing that changed was the mean, choice 3. Okay. Last but not least, we are just going to quickly do some dot plots and interpret them. So a dot plot, we just put a dot above each one. Nice and easy. This says students from River City High School were randomly selected and asked, how many pets do you currently own? The results are recorded below. Make a dot plot of the data set. So that already did the number line for us. The number of pets is there, 0, 2, 4, 6, 8, 10, 12. So what we do, you see there's 4 zeros. So I'm going to put 4 dots above 0. 1, 2, 3, 4. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. So where the 1 would be, we're going to put 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 1, 2, 3, 4 twos. 1, 2, 3, 4. There's 2 3s, 1 4, 2 5s, 2 6s, 1 7, 1 8, 1 9, 1 10, 1 12. That's it. That's a dot plot. Okay. The next part here says calculate the mean number of pets owned by the 30 students and calculate the mean or the median. So the mean, let's go through and add them up. You can do the 4 zeros if you want. That's up to you. So I have how many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ones plus 4 twos, 2 3s, 4, 2 5s. So I'm getting, when I add them all up, I got 96. They told us there's a total of 30 students. So the average number of pets owned is 3.2. That makes sense. Okay. The next part wants us to calculate the median. So they are in order just from top to bottom. So I'm going to cancel out. There's 30. So let's cancel out like, how about 14 each? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How about on the other side? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I have 2 numbers. Remember, when you have 2 numbers, you add them up and divide by 2, but they just both happen to be a 2. So 2 plus 2 divided by 2, 4 divided by 2 is 2. So the median is 2. That's it. Dot plot, mean and median. Let's look at this one. It wants us to make a dot plot again. It says, it already gave us the number line. It says 20 students, each rolled a pair of dice, recording their results in the table below. Make a dot plot of the data set using the following scale. So we have 1, 2. And this one's kind of all over the place.
What is this place?
So I have a 6. I'm just going to go down the line. I have a 4. I have an 11. I have a 9. I have a 5. You see I'm skipping. I have a 7. Then I have another 7. I have a 3, a 12, another 5, another 6, another 10, an 8, an 11, a 7, an 8, 7, a 6, a 7. There we go. So this looks pretty symmetrical. What is the mean of the pair of dice results? So let's add it up. Again, I'm just going across horizontally. So 2 plus 6 plus 4 plus 11 plus 9, 5. The biggest trick with this is not mistyping a number and not missing one, which is sometimes what I do. Okay, so I have for my mean, I got my numerator 141 when I added them. They told us there's 20 students, so I'm going to divide it by 20. And I got 7.05. So that was the average roll, so 7.05. What is the median? Now, again, the top table is not in order. However, my dot plot is. So for this one, I'm just going to use my dot plot and cancel out. There's a total of 20 students, so the middle numbers should be like around 10, right? So let's cancel 9 from each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 2 7s in the middle, so when you add them up and divide by 2, your median here is going to be 7. It says, is the mean or the median a better representation? Well, guess what? This data is symmetrical. We're going to write that down here. Notice, aren't your mean and median pretty much the exact same number? So really, both are good. Typically, when your data is symmetrical, we use the mean to describe it. So not bad, okay? Questions? Oh, right, you're not here. I'm just talking to myself. So let's go to the next one. It says 25 car owners were asked the age of their cars. The results are recorded below. So one person has a brand new car, 0 years old. And then some people have cars that are 8 years old, okay? It says make a dot plot. So let's do that. And I like this one because, again, the data is already in order for me. So I see there's 1 0, there's 1 1, there's 2 2s, there's a 3, a 4, 2 5s, 3 6s, 1 2 3 4 5 6 7s, and 1 2 3 4 5 6 7 8 8s. Okay. It says describe the distribution. Is it symmetrical? It is not. This is left skewed. As soon as it's skewed, the mean is no longer a good representation, just so you know. The median is going to be the best. So let's see what it asks. It says, what is the mean age? So let's do the mean. Add them all up. I think I got 146, but I think I might have done it wrong. 146 divided by the total of 25. So 5.84. So the average age they're saying is 5.84. Let's do the median. You can either use the table or your box plot, up to you, because the table is in order. So I'll use the table. There's 25. So let's do 12 on each side. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The only number left is 7. So the median is 7. It says, why are the mean and the median different? The reason that they're different is because the data is skewed. When the data is symmetrical, the mean and median will be pretty much the same. Okay? So what number would we use to estimate a typical age of the car? For this one, we're going to say the median. And a great explanation for this is because why we would use that? Because the data is skewed. If your data is skewed, the median best represents it, which makes sense. Okay, the mean was 5. Does 5 represent like a good age of these cars? No, most of these cars are older than 5 years old. They're 6, 7, and 8 years old. Okay, so the 5 doesn't represent it well. So again, for symmetrical data, the mean is typically the one that we choose. All right. And for skewed data, the median is going to be better. Always the case. So that's it. Mean, median, mode, range, and a dot plot today. Hopefully it wasn't too bad. Just remember again, if the data is symmetrical, you're going to pick the mean. If it's skewed, you pick the median. Nice and easy. Complete all of homework 2. Email any questions. Join our Google Meets. A couple days left. So exciting.
Oh my God! Santa!